I am not encouraging or advising anyone to modify their firearms. This is for entertainment and educational purposes only. What's up, everyone? I want to tighten the slide to frame fit on this Mac 9 DS. It's disrespectfully loose. It's a cheap 1911, so the slide to frame fit wasn't great to start with, but the clearances opened up even more as the Cerakote on the frame rails wore off with use. I have myself a tactical Turkish maraca, and I don't really want one. This will be a very technical, in-depth video on the 1911 slide to frame fit. This seems to be another contentious topic in the 1911 gunsmithing world. Please keep in mind, I'm just a dude playing a dude disguised as another dude. I'm not an expert nor a professional gunsmith. I don't have all the answers. I'm trying to gather enough information to effectively do what I want to do on this pistol. Hopefully I can present and explain what I've found in a way that others may learn from. At the end of the video, I'll demonstrate one process for tightening the slide to frame fit on this pistol and hopefully not screw it up. I haven't done this before. It's going to be a lot of fun. Let's get into it. I think a good place to start is to look at the original 1911 slide and frame designs and their dimensions. These dimensions all come from the M1911 book by Jerry Kuhnhausen. Here are the dimensions in question. They are given as upper and lower limits. This drawing is a bit busy. I'll simplify it. Let's take a look at the frame dimensions in question first. I will put the nominal values next to the given limits. I'm not going to read these out to you. Pause the video if you want a closer look. Here are the slide dimensions in question, isolated with their nominal values given. I've created a 3D model representation of the 1911 slide and frame rail areas to help us visualize this. The dimensions are all at their nominal values I just showed. I made them different colors for clarity. Sorry, I didn't pick the colors. The software did, and we got salmon and baby shit yellow. There are two rail interfaces, this one and this one, which I will refer to as upper and lower. Slide to frame clearance will have a vertical and horizontal component, and we are only going to consider these clearances in two dimensions for the time being. Initially, I've constrained the model to show even gaps on all sides of these lower rails. As far as I can tell, when talking about slide to frame clearance, it is given as total clearance, not clearance per side. In this case, the total clearance of the lower rail would be the sum of these two gaps in the vertical direction and these two in the horizontal direction. I'm focusing on the lower rail interface for a reason that I will explain shortly. At the nominal dimensions, this vertical gap is 2 thousandths, giving us a total clearance of 4 thousandths. This horizontal gap is 2.75 thousandths, giving us a total clearance of 5.5 thousandths. These nominal clearance values are in line with what is presented in the Kuhnhausen manual for an ordnance specification military 1911 pistol. Now I have constrained the slide and frame in a way that shows total clearance for clarity. The slide is pushed up and all the way to one side. The vertical clearance range at this lower rail is 1 to 7 thousandths. The vertical clearance range of this upper rail is 1 to 9 thousandths. The horizontal clearance range of the lower rail is 1 to 9 thousandths, and the horizontal clearance range of the upper rail is 2 to 11 thousandths. I played with the dimensions of the slide and frame rail models within their tolerance range, and I found that in an extreme case, the upper rail can dictate the slide to frame clearance in both the vertical and horizontal directions. However, the clearance ranges of the lower rail are narrower than the upper rail, so I'm under the impression that the lower rail interface is what is designed to dictate the fit and clearances of the slide and frame in the original design. I could be wrong, that's just my interpretation of these dimensions. That's why I was focusing on the lower rail just a moment ago. There's one measurement method described in Kuhnhausen where feeler gauges are used to measure the horizontal and vertical clearance. Putting a feeler gauge between the bottom of the slide and the top of the frame, as shown at position B, would push the slide up, and the clearance measured by the gauge could be dictated by the vertical clearance at the upper or lower rail. Putting modified feeler gauges in the two positions labeled A would show the minimum horizontal clearance, and presumably the minimum clearance could show up at the top or bottom rail interface. It seems to me when taking measurements of the rails and calculating clearances, the fit of the slide to frame would just be the minimum clearance measured in the horizontal or vertical direction, regardless of which rail interface that minimum clearance shows up at. There is a discussion that could be had about the tolerance stacking of all these dimensions in the horizontal and vertical directions. The vertical tolerance stack is the only one mentioned in the Kuhnhausen manual. It is not mentioned in relation to the clearances we are discussing, but the needed barrel length in the upper barrel lug engagement. And I think that's kind of outside the scope of this video. So what should these clearances be in the horizontal and vertical direction? Well, it depends. We have seen the range of clearances that would be deemed acceptable based on the original ordnance specification tolerances. I will be sharing some clearance ranges based on the application of the pistol given in the Kuhnhausen manual because they seem reasonable to me. Before that, I want to share this very important quote. There is no absolute slide frame rail slot clearance specification applicable to all categories of M1911 type pistols. These clearance ranges apply to both the horizontal and vertical directions. 4 to 6 thousandths for military and ordnance specification commercial 1911 pistols. Pistols for bullseye competition use might have clearances of 1/1000th of an inch or less. Pistols for other competition use may have clearances from 1 to 1.5 thousandths. Point number 4 seems a little vague to me. I will share my interpretation. If someone is assembling a 1911 pistol and they want the fit to be improved or better than the nominal clearance associated with ordnance specifications, a slide to frame rail clearance of 1.5 to 2 thousandths is suggested. When I hear the words carry pistol, I think of a concealed carry or duty pistol that someone is going to trust their life to. If that is the case, I would argue that this clearance range would also suffice for general use pistols. Here are some final considerations regarding the slide to frame clearances we have been discussing before we go on to the tightening techniques and demonstration. For the sake of simplicity, we have been considering these clearances in 2 dimensions and have made various other assumptions to get an accurate idea of the clearances and how much they vary. Measurements would need to be taken along the whole length of the slide rails on both sides of the slide and frame. If a gunsmith were fitting a slide and frame together for the first time, they could presumably dictate what clearances they want and where they show up. Their fitting methods would determine how uniform those clearances are along the length of the rail. Their required precision would vary with the desired fit. Horizontal clearances and the position of the slide on the frame can affect firing pin placement on the primer, how cases interact with the slide and extractor as they're stripped out of the magazine, and where the ejector contacts the case rim as the slide moves rearward. In addition to all that, the vertical clearances can affect barrel lug engagement and lock up the needed barrel length, disconnector function, and how the barrel lugs contact the vertical impact face in the barrel bed of the frame. There are likely some consequences of the slide to frame fit that I am also not aware of. That wraps up what I found in my research on the slide and frame rail system in the 1911 and my current understanding of it. Obviously, I don't have all the answers, but I think I have a good enough understanding to do what I need to do at the moment. Why would you want to tighten up the slide to frame fit on a 1911, and what are the drawbacks of doing this? The Kuhnhausen Colt 45 ACP manual on page 110 lists some great reasons, so I'm just going to share those. Reasons to tighten the frame include increased accuracy, especially when paired with other barrel and bushing accurizing work. If the slide and frame rails are tightened properly with a good deal of accuracy and uniformity, bearing surface is increased and it may minimize point contact wear. General feeding reliability can increase when the slide comes forward in the same relative position each time. One thing I will add to the list of advantages is that it just makes the pistol feel nicer. More expensive, higher quality 1911s have tighter slide to frame fits. That's the reason I want to tighten up this pistol. I'm not so concerned about accuracy. This thing is plenty accurate for my purposes. Drawbacks include cost. It's a labor-intensive process. It takes special tools. There may be refinishing needed after it is done, which also adds to the cost. By itself, it may not increase accuracy all that much, unless done in conjunction with other accurizing modifications. Tighter rails have less tolerance to dirt and grit, so more frequent cleaning may be required. I've heard contact wear may increase if the tightening is done poorly or non-uniformly across the rail length. I could see how this would be the case if only a few points were tightened up. Those high spots would likely wear off in a hurry, putting you back at your starting clearances, maybe slightly looser. There are a few ways to tighten up the slide to frame fit on a 1911. All over the internet, there are lots of strong opinions about the proper techniques and if certain methods should be used at all. Once again, I will be referring to the Kuhnhausen manuals. I think they're a great, reliable source and a good starting point for this discussion. The Colt 45 automatic manual contains a lot of information about this. There are some techniques that primarily tighten vertical clearances, one that tightens horizontal clearances. Then there are a couple methods that can tighten both that aren't listed in this manual that I have seen elsewhere. A method that I won't discuss is replacing the frame with one that has oversized rails and fitting it to your existing slide. This video is concerned with tightening the relationship between an existing slide and frame pair. Let's start with the methods that tighten vertical clearances. There is peening, which is broken down into different techniques in this manual, and then there is swaging. There are some considerations common to peening and swaging. I've read that Peening or swaging aluminum frames is not advised as they're more delicate and prone to cracking. There's no mention of aluminum frames in the Kuhnhausen manuals either. Only peen or swage the front and rear 7/8 to 1 inch of rail section. It's not recommended to try and tighten up the thin rail area in the center of some frames as it is delicate. Some frames don't have the center rail section like this one that I will be demonstrating on. The front frame rails on frames with ramped barrels will be more delicate like this one with the Clark Para ramped barrel. There is no elevated barrel bed joining the two rail sections like on a frame with an unramped barrel. Jigs or fixtures to hold the frame while you do this are recommended for both methods. It is best to use gauge bars with both methods. They act as a die so the vertical clearances don't get over tightened. These methods may tighten up horizontal clearances slightly as the metal is moved down. It may kind of squish outwards a little bit too. Rail dimensions and parallelism should be checked, and some final cleanup will likely need to be done after either of these methods. The instructions that come with the swaging punches from Brownells also have some pertinent information that would apply to both swaging or peening. The first being that the frame needs to be completely stripped and the ejector needs to be removed. It's in the way of swaging or peening down the rear rail section. The other important information here is that you should expect your frame finish to be marred or damaged during this process, no matter how well you fixture or clamp your frame. Peening is pretty much just hitting the frame rail areas with a hammer to move them downwards and tighten up the vertical clearances. There are 3 different peening methods given in this manual. The bevel method kind of just bends the rails down. The issue with this is that you would only have a small point of contact here. It would likely wear quickly, opening back up your vertical clearances. The peen down method more evenly lowers that rail all along its whole length. The modified peen down method is the same as the peen down method, but the thin rail section along the sides of the magazine well are not peened. This seems to be the best peening method, giving the most contact area and least chance of damaging the thin rail section. How do you control whether the rail is bevel peened or peened down? I don't really know. My guess is to achieve the peen down results, you just got to hit it more. Maybe with the bevel method, slide fitting bars aren't used or something. This method will be harder and require a great deal of skill and experience. The area that needs struck with the hammer is a pretty small target, and there is a high chance of frame damage if done improperly. It is important to use a hammer that has a very smooth and blemish-free face. Any dings on the hammer will get transferred into the frame rail surface and can permanently damage it, or at very least require more cleanup after you're done. Swaging is similar to peening, but instead of directly hitting the frame rail with a hammer, a specialized punch is used. This should make the process easier because it helps the force be repeatably delivered to the frame rail in the same spot every time, only where it's needed. There are single-sided and double-sided swaging punches for adjusting one rail at a time or both. It seems to me doing one side at a time would be best. It would presumably require less striking force and only 1 gauge bar instead of 2. The Kuhnhausen manual recommends horizontal clearances be tightened up after the vertical clearances are set and the frame rails are cleaned up. That makes sense to me, but this order of operation seems to be argued about. Horizontal clearances are tightened by squishing the frame rails inward in a vise. There are also some special tools sold to do this as well. This is pretty sketchy, and I'm kind of scared to do this on my slide. This manual gives a great description of how to do this in a controlled and repeatable manner, which I will be following very closely. It will require a lot of patience, making very small adjustments, taking measurements, and repeating until desired final dimensions are met. Now onto the 2 methods that can tighten both horizontal and vertical clearances that are not mentioned in the Kuhnhausen manual. First is AccuRails. Installation of these requires machining the slide in the frame to install some hardened steel rods that will then become the primary rail interface. To me, this seems to be the only method appropriate for aluminum frames. If properly machined and installed, presumably very tight clearances could be achieved with this method. Welding the frame rails to add material only where needed, then remachining them to match the existing slide could tighten horizontal and vertical clearances and produce some very tight tolerances depending on the quality of the machine work. I don't think this would work on an aluminum frame for a couple of reasons. Aluminum is much harder to weld than steel, but more importantly, most aluminum pistol frames will likely be anodized. The aluminum oxide layer on the surface of an anodized part is non-conductive and cannot be welded. It needs stripped off, which is a very aggressive chemical process, usually done with strong caustics or acids. This could change the rail dimensions significantly depending on the thickness of the anodizing layer, sometimes 1/1000th of an inch or more. Then the whole frame would need to be re-anodized afterwards. It doesn't seem reasonable to me, which is why I think AccuRails are the only viable option for aluminum frame 1911s. Before tightening the clearances on a slide and frame, it would probably be helpful to know what the existing clearances are so we know what to tighten up and by how much. The required measurement tools and accuracy will be dictated by the desired final slide to frame clearances. If you want a clearance less than 1/1000th of an inch for a bullseye pistol, you better have tools that can accurately measure to the 10,000th of an inch. If your desired fit is somewhere around 2 to 3 thousandths, you can probably get away with plus or minus half a thou accuracy. Quality measurement tools can get very expensive very quickly. Micrometers, inside micrometers, groove micrometers, a quality gauge pin set, and some special tools specific to the 1911 would be needed for a very tight slide to frame fit. Let's finally get into the tightening demonstration. I will be swaging the frame rails down to tighten vertical clearances and squeezing the slide to tighten up horizontal clearances. This is a general use range toy pistol for me, so I'm not going for a crazy tight fit here. I'm targeting about 2/1000ths clearance in both the horizontal and vertical directions. I feel using these calipers for my measurements will be sufficient as their accuracy is plus or minus half a thou, and the tightening methods I have chosen will hopefully work well to achieve my desired clearances. I will be doing this at my dad's house to use the big stable vise on his mill. He has micrometers and nicer calipers over there I can use for more accurate measurements if needed. I ordered swaging punches, a slide and frame rail file for final cleanup, and a 117,000th slide fitting bar, all from Brownells. I will show how I determined the thickness of the slide fitting bar I needed in a moment. In addition to the calipers, I needed a couple of gauge pins that fit in the frame rails to take my measurements. They need to be less than 100 thou in diameter, so I ordered two 90 thou gauge pins from Amazon. Before taking any measurements, make sure to clean the slide and the frame rails very thoroughly. I've also removed the thumb safety to get it out of my way. I'm going to be doing these measurements pretty quickly for demonstrative purposes. Obviously off camera, I'm going to spend more time getting accurate measurements and recording them all so I can then calculate my clearances. The insides of these grooves here are pretty easy to measure with calipers on the front and the back because there's no joining frame rail section. So I can just do that. I can sneak my caliper tips in just like that. I can do that on the rear frame rail section as well. The other way to measure that groove width is to stick the gauge pins in there, get a measurement, and then subtract the two diameters of the gauge pins. In this case, these are 90 thousandths each, so I would be removing 180 thousandths. Keep in mind that if you put these gauge pins in the frame rails, you will effectively be averaging out the dimension of that frame rail across the length of this gauge pin, and so you may not see those very, very small variations that you would see if you did more individual point measurements. Pretty easy to get in here all the way along the length and get the measurements that I need. Measuring the slide rail inside dimension is pretty straightforward and easy. Getting the groove dimension is a little bit more difficult, but that is where our gauge pins come in. I can just reach in here and measure between my two gauge pins, and then I would be adding the diameter of the two gauge pins to my measurement to get the dimension from here to here. Groove and rail height is a little bit more difficult on the slide. This is where if you wanted to do it really accurately, you would have to use a groove micrometer. I can't get in here and measure the groove or the rail with my calipers accurately. So the only place I can get my measurement is just right at the back here, which of course is suboptimal. but that is okay. The clearances I'm trying to go for, I don't need crazy accuracy here. So this is going to give me an idea. One critical dimension called out in the Kuhnhausen manuals as it relates to the vertical tolerance stack of the slide and the frame rails is this dimension right here. The height of this rail needs to be a minimum of 114 thousandths, and that is so it spaces this part of the disconnector rail above the frame high enough for proper disconnector function. This is a really busy diagram. My apologies. I need a bigger whiteboard. I have carefully measured all the rail dimensions of the slide and the frame and have recorded them here. Most values were measured along the whole length of the rails, and the measured variation was plus or minus half a thou, which is the measurement accuracy of my caliper, so I'm feeling pretty good about those measurements. These ones with the blue stars are the ones that were difficult for me to measure because I don't have a groove micrometer. So there's more uncertainty associated with them. I could only measure them at the rear of the slide and not along the whole length of the rail. Any dimension or clearance with a purple box around it is out of spec according to the ordnance diagram dimensions that were shown earlier in the video. You can see the frame is out of spec in 3 places. The top and bottom rails are too narrow, and the upper rail height is under the minimum spec. An important dimension for proper disconnector function, as described in the Kuhnhausen manual, is this slide lower rail height. It needs to be more than 114 thousandths, which mine is, so I am good to proceed with the vertical clearance tightening. Let's look at the clearances of the upper rail first. 7 to 9 thousandths in the horizontal direction and 5 to 8 thousandths in the vertical direction. The horizontal clearance range I measured at the lower rail is out of spec at 8 to 10 thousandths. It should be no more than 9 thousandths. And the vertical clearance is 3 to 5 thousandths. So it looks like my upper rail is determining my horizontal clearances and my lower rail is determining my vertical clearances. A quick and easy check with the vertical clearances is feeler gauges. I can fit this 4 thousandths feeler gauge in between the slide and the frame all the way along the rail on this side. I can fit a 5 thousandths gauge in on the other side. So that means what I'm measuring with my feeler gauges falls within my calculated vertical clearance range at the lower rail. With the swaging process, the vertical clearance at the lower rail of the frame will be tightened by reducing this dimension, and I want the final clearance to be about 2 thousandths with the lower slide rail. I measured this lower slide rail height to be between 115 to 116 thousandths, so that's why I got 117 thousandths thick slide fitting bar. I will swage the rails down until they stop on the slide fitting bar, and that should set my 2 thousandths clearance with the lower end of my range, that 115 thou dimension. And then when I do my final cleanup and smooth out the rails, I will likely hit that 2 thousandths clearance with my upper 116 thousandths dimension. After I do the vertical tightening work on the frame, I will need to remeasure all of my width dimensions on the frame and recalculate all the horizontal clearances before I start squishing the slide. As I mentioned before, there's a possibility a little metal will move outwards as the frame rails are being swaged down. As I mentioned with peening, the hammer face needs to be very smooth and blemish free so it doesn't imprint anything into the frame rails. This swaging punch has kind of some little rough edges from the manufacturing process. It looks like this profile was wire EDM'd. This is the actual surface that interfaces on the frame rail. I'm just gonna clean this up a little bit before I start. Just barely broke some sharp edges and hit the face of it with some 1000 grit sandpaper. Got my slide and frame fully stripped and got the ejector removed. I can feel some edges on these frame rails, so I'm gonna clean these up really nicely and carefully with a fine file and some stones before I do my swaging. I will show the final cleanup procedure after I'm done swaging these as well. First order of business was to make some sort of fixture or jig to hold the frame while swaging. If this were a single stack 1911, I would have likely just bought a fixture. Luckily, my dad has a bunch of material laying around his shop, so I got to work milling some aluminum to the size and shape I needed. First, a platform for the frame to sit on that supports the front and rear sections and has a relief hole for the tab that the trigger guard screw goes through. then 2 strips to take up the space of the horizontal step in the frame where it goes from the narrow front section to the wider rear area for the double stack grip module. Here you can see all 3 parts as they will be supporting the frame in the vise. Before clamping this in the vise, I used thin solid cardboard and painter's tape to protect the delicate shitty Cerakote finish. I had to stack some bars of aluminum under this fixture in the vise to space it up to the height that I needed. Once solidly clamped, I put my slide fitting bar in and started swaging the rails down. This was a long, nerve-wracking process. I had to hit it so much harder and so many more times than I thought I would. I caught the frame moving in the vise a couple of times and had to pull it out and make adjustments to my fixturing. On each of the 4 individual rail sections, I stopped swaging when the slide fitting bar was a snug fit in the groove. The front rails swaged down easier than the rear. My guess is because the rear rails have much more material under them and joining them. After the swaging was done, it moved a significant amount of material outward, meaning my upper frame rails were now too wide and pretty fucking mangled and uneven. I had to file them back down until I reached an even width along the length of the front and rear rail sections. The final finished width dimension after cleanup was 0.749 to 0.750. Before the swaging process, they were 3 to 4 thousandths narrower than that. After the frame rails were uniform width and parallel, I broke some sharp edges on the corners and called it done. Now, after swaging with the upper frame rail becoming wider, I confirmed my upper and lower slide rail widths, and I only needed to squeeze the slide 2 to 3 thousandths to achieve my desired horizontal clearance with the upper rail of the frame. Since we're primarily concerned with the clearances at lockup for the repeatability of the slide coming back forward into battery, I'm only squeezing the rear 3 1/4 inches of the slide. This is roughly the total length from the front to rear rail sections. This is also called out in the Kuhnhausen manual. I spaced it up on parallel bars so the vise jaws were only grabbing the lower 1/8 inch of the slide. I made sure my vise jaws were completely clean, smooth, and blemish free so I didn't damage the slide finish. The Kuhnhausen manual says to compress the slide 20 to 25 thousandths of an inch. There was no way in hell I was starting there. I wanted to sneak up on it. I set up a dial indicator on the vise with a magnetic base and zeroed it. You could also use calipers for this, as shown here. I started by squeezing it 5 thou, let it sit 20 seconds, hit the vise with a hammer to relieve stress, unclamped it, and measured it. It didn't close up at all. I repeated this process, but squeezed it 10 thou, then 15, then 17.5, then 20. Finally, once I squeezed it 20 thou, let it sit, smacked the vise, and unclamped it, the width closed up about 1/2 to 1/1000th of an inch. Interestingly, look what happens to my dial indicator when I smack the vise to relieve the stress. The slide material relaxes slightly, and the jaw of the vise moves in about another 1/2 thou. I repeated this, squeezing the slide 20 thou at a time, checking, resetting 0 on my dial indicator until I reach my desired width dimension. Let's look at the results. Here are the final vertical clearances after the swaging work. My lower rail interface was dictating the minimum vertical clearance before with a range of 3 to 5 thousandths. Now I am measuring a clearance of 2 to 4 thousandths at the lower rail. You can see the vertical clearance at the upper rail opened up. That is because I effectively made the upper rail thinner by bashing it down. Let's see if the feeler gauge test agrees with my measured and calculated values. On the left side, I can fit a 2 thousandths gauge in the rear rail, but not 2.5. And at the front, I can fit a 3 thou gauge in, but not a 4. At the rear rail on the other side, I can fit a 2.5 thou in, but not a 3. At the front rail, I can fit a 3 thousandths in, but not a 4. This is within the range I measured with the calipers and calculated, and pretty close to what I was targeting. The clearances vary slightly from side to side and from front to back. The swaging process was awful. I really hated it. I'm not doing it again. It was so hard to repeatedly deliver enough force to the rails to do what I needed to do. Even with the swaging punch, it's only hanging on to the rail by about 60 thousandths. Hitting it hard enough with the ball peen hammer I was using made it bounce around and gouge the frame rails. It looks like a dog chewed on them. It mangled them so badly that it took me a really long time to clean them up with a file. I'm definitely going to put some cold blue on these frame rails to hide my shame. Yeah, dude, that's pretty fucking gross. I didn't quite tighten up the clearances as much as I wanted or as consistently as I wanted across the rail area. I could have probably done with a 1 to 2 thou thinner fitting bar as well. My fixturing worked really well. I cannot see any damage on these areas of the frame where I had it clamped. The only damage I see is a little bit of marring right here. That fixture took me an hour to an hour and a half to make before I even got to the swaging process. That was another big pain in my ass. Here are the final horizontal clearances before my minimum horizontal clearance of 7 to 9 thou showed up at the upper rail, and now after tightening the clearances 1 to 3 thousandths. I tightened up the horizontal clearance 4 to 8 thousandths at the upper rail. Remember that this is partly from the upper rails getting 3 to 5 thou wider due to the swaging, as well as me squeezing the slide 1 to 3 thou. At first, squeezing the slide was really sketchy. To get it compressed 20 thou, I had to put a concerning amount of force on the vise handle. Once I got a feel for it and I wasn't scared of cracking my slide in half, it was a pretty repeatable process that produced consistent incremental half thou to 1 thou slide rail width reductions. This slide has a nitride finish. My vise jaws were clean and blemish free, but you can still see a faint line right here. I should have probably put some masking tape on this at least. It would have made my measurements of compression slightly less accurate, but not enough to affect the results. As I said, I'm not swaging frame rails again. I would, however, squeeze a slide again. If I didn't swage the frame rails, could I have squeezed in the slide the 8 thousandths maximum to take up all the clearance that I wanted? I'm not so sure. So, how does it feel? Pretty good. I achieved what I wanted. I'm pretty pleased with the results. The slide to frame fit feels noticeably better. Let's do the old shake test here. Oh yeah, much better. Not nearly as rattly or percussive. I'll see how tight it stays with the inconsistency in rail clearance from left to right and from the front to rear rail sections. At this point, I'm really over this project. It is what it is, and it's going to wear how it wears. If it loosens back up, so be it. I don't do these projects because it makes sense financially. I do them because they are fun for me and I enjoy the learning and discovery process. I have had a great time researching and creating this video. I found that I hated the actual tightening process and likely won't do it ever again. This was one of the most difficult and time-consuming projects I've ever done on a 1911. I obviously have a lot of equipment and tools available to me that most people do not. I still had to spend about $200 on tooling to do this. If you didn't have the vise and the measurement equipment and the material and skill to make a fixture, you could easily spend $500 or more. I don't think this is a reasonable thing for the hobbyist or enthusiast to do. I can't imagine it would be very cheap to have a gunsmith do it either. My recommendation is if you want a 1911 with a tight slide to frame fit, pay for it up front, just buy a nicer pistol, you will be money ahead. I understand the utility of these techniques in certain rare cases, but leave that to a professional gunsmith who has experience doing this, so it doesn't end up looking as shitty as mine with non-uniform clearances. That wraps it up. I learned a lot. I hope you did as well. As always, thanks so much for watching. I'll catch you next time.